All right. What's going on? As you know, you have a quiz this Thursday. So I wanted to make the review for you. Shout out to Ms. Etheridge for putting it together, and I'm gonna drop a video for you. So let's get started. County Principal Quiz Review. The American Red Cross says that about 45% of the U.S. population has type O blood, 40% type A, 11% type B, and the rest has type AB. Alright, someone volunteers to give blood. What's the probability that this donor has type AB blood? Alright, so AB blood, right? Says the rest is AB blood. Well, we know that type A is 45, right? We know type O is, 45 is O, 40 has A, and 11 has B. Well, that right there is going to be 96%, right? That's 85, 96%. So if I do 1 minus 0.96, it's going to give me 0.04 or 4%. All right, 4% of the population has AB. All right. Now, B says, what is the probability that they have type O or type A? Now, there's that key word, guys, or. Whenever you see or, we add. All right, or it means add, and means multiply. All right, so we have this keyword or right here. So or means add. So type O is 45 or 0.45. Type A is 40 or 0.4. So we multiply those, and that gives us or means add. Add. And I just wrote add. So it's 0.85 or 85%. Now, for this last problem right here, it says does not have type O blood. So all we need right here, not means subtract. So 1 minus, alright, 1 minus O, and O is 45%, so minus 0.45, and that's going to go 0.55. Sorry, that's terrible 5, so 55, which is 55%, and that's terrible 5 again. Alright, now right here, number 2 says, using the same percentiles from problem 1, 5 people are waiting in line to donate blood. What is the probability that part A says that they all have type A? Well, type A is 40%, right? Type A is 40%. The probability of A is 40%, right? So all of them, what I'm going to do is I'm going to do 0.4 times 0.4 times 0.4 times 0.4 times 0.4, or 0.45 times. All right, that gives me 0.0102 right there, or 1.02%. All right. This one right here says the third one is the first one that has type AB. So basically, the third person is the first person to have type AB. All right. So what's the probability of the first person not having AB? Well, let's look at what AB is. AB, the probability of AB, they said was 4%. 4%, right? So AB we said was 4%, right? We got that from right here. So if AB is 4%, well, we know the first person, well, think about it. 1 minus 4%, or 0.04, is 0.96, right? So the probability that the person has AB is 4%. The probability that the person does not have AB is 96%, right? So we got to look at it like this. The probability of the first person, all right, the first person, because we said the third person is the first person to have AB. That means that the first person doesn't have AB. So that's a 96% chance, right? And then we said the second person, all right, does not have AB, right? So that's 96% chance as well. So now we get to the third person. Well, they have a 4% chance of having AB blood. So what I need to do is multiply that. So I'm going to do 0.96. So bear with me. 0.96 times 0.96 times 0.04. I had to punch that in my calculator, and that's going to give me a 0.036. 0.036864, or a 3.7% chance. 3.7% chance right there. Okay. Now, right here, number 4. Number four tells us if, wait, is that number 4? It's number 3. Good night. I can't add. I can't count. Sorry. Number 4 says if you roll a fair die 4 times, and a fair dice is 1 dice. Right? You used to dice, where we shoot craps, or on the crap table at the casino. What? 1 die, just 1. You roll a fair die 4 times. What is the probability that you roll all 2s? All right, yikes. So, all right, let's look at 1 die. Right, the probability of rolling a single 2 is 1 out of 6 because a die has 6 sides. Right. Now I want to roll this 4 times. All right, I want to roll this, so I have a 1/6 probability. All right, 4 times. All right, 1 out of 6 probability 4 times. Right. So for the first roll, I got a 1 out of 6 opportunity. For the second roll, I have a 1 out of 6 opportunity. For the third roll, I have a 1 out of 6 probability, and for the fourth, I have a 1 out of 6 probability. Alright, so I'm just going to multiply that. And remember, you multiply straight across. So 1 times 1 is 1. And 6 times 6 times 6 times 6 is 1,296. Or we could say 0.0008. Alright. Now, if you draw cards from a deck without replacement, that means I draw a deck and I never put the card back. So, first of all, it's 52 cards in the deck. Right? 52 cards in the deck. So I draw a card without replacement. That means I take a card out. What is the probability that I draw a diamond first, then a red card? So the probability of drawing a diamond right now, let's look at this. How many diamonds are in the set? All right. Well, there are 13 diamonds in the set. All right, 13 diamonds. All right. So I draw the diamond. So I drew a diamond card. Let's say it doesn't matter. I drew a diamond card out. All right. So now, how many cards are left in the deck altogether? Well, there's 51 cards left in the deck for my second pull. All right, so now I'm about to have my second draw. All right, but this time I'm looking for a red card. And how many red cards in the deck? Well, think about it. Half the deck, all right, half the deck is either red or black, right? So there's 26 red cards. There's 26 black. Alright, but you also must consider that the red cards are diamonds and hearts. The black cards are, that's my best spade and clubs, right? So I already pulled out a diamond. So this 26 has been reduced now to 25 cards. I know I pulled out a diamond. It's also a red card. Alright, so now it's only 25 cards. So now I'm going to pick from 25, right? Because the next card just needs to be a red card. So 25 out of 51, okay? So 13 out of 52 represents the number of diamonds in the set, right? In the deck of cards. And then when I pull out my diamond, it's over here now. It's no longer in this deck, so it's not 52 cards, now it's 51 cards. And then I got to pull from all the red cards. Well, there's 26 red cards in the deck. I already pulled out 1 diamond, which is a red card. So now there's only 25 cards left in this deck that could be red. So I'm just explaining that to you again. So anyway, and because think about it, we had to pull out a diamond and we had to pull out a red, right? It's just then. All right, then. So let's and we're going to multiply. All right. Or this is the probability of a diamond. Oops, that's a triangle. Good night. I can't draw. Let me try again. Probability of a diamond and red. Alright, so there we go. So that gives us, when I multiply that, that's going to give me 25 over 204, or you could say 0.1125 or 12.25. I'm sorry, 11.25% right there. Alright, I spent way too much time on number 4. But anyway, alright, let me make this one bigger so I can have space to make my tree diagram. I know you can't see it. I'm going to read it here on my sheet. It says, a recent Maryland highway safety study found that 77% of accidents, the drivers were wearing a seatbelt. Accident reports indicate that 92% of those drivers escaped serious injury. Alright, but only 63% of the non-seatbelt drivers were fortunate. What is the probability that a randomly selected driver involved in the accident didn't have his seatbelt on and suffered serious injuries? Alright, so this one, let's look at it, right? We're going to start off with drivers, alright? I'm going to start off with the drivers, and I have seatbelt drivers and non-seatbelt drivers, alright? So of the seatbelt drivers, it said 77%, alright? 77% of the seatbelt, of all drivers, of all accident drivers were wearing a seatbelt, alright? So now that means, right here, because you got it, every branch must, every branch right here must equal 100%. So this is 77. This must be 23. All right, 23%. So I want to go 0.77 and 0.23. Now they said. So now, continuing with the problem, it says that accident reports indicate that 92% of those drivers escape serious injuries. So of the 77% that wore their seatbelt, alright, 92% or 0.92 did not have accidents. Alright, so that means if you think about it, remember each branch must equal 100%. I said this equals 100% or 1. 0.92 plus 0.08 equals 1, right? And this is serious injury and non-serious. And then for this one, all right, it says, where am I? Oh yeah, it says, but only 62% of non-belted drivers were so fortunate. So that means, all right, out of the non-belted drivers, 63%, all right, or excuse me, had severe, right? So non-severe, or 63%, all right, escape injury, all right, they escape injury, all right, which means, again, each branch must equal 100%, right? So this branch right here, if you add this up, that gives you 0.37. 100 minus 63 is 37, right? So what we can do now is we just follow the appropriate branch. Alright, so we use a little highlighter to do that. And it says right here, the actual question is, what is the probability that a randomly selected driver involved in the accident didn't have a seatbelt? Didn't have on the seatbelt, so non-seatbelt driver, and suffered serious injuries. So, you know what, here, let me relabel this real quick. Alright, so that gives us 0.23, right? And, so it's multiplication, 0.37. Right? And that's going to give us a 0.0851 or 8.5. What in the world? Some hacker. Man, sorry about that. Somebody spam my comments on YouTube. Anyway. So 0.815%. Man, I lost my train of thought. I had to go fix that. Now, alright, number 6. It says the ugliest. Oh, crap. Alright, the ugliest pet contest is made up of $7 and 3 cats. If 3 different pets are randomly selected to participate in a special performance, what is the probability that all 3 of them are dogs? So again, the probability that all 3 are dogs, that means that there's no replacement. So again, there's 10 total animals, right? 10 total animals. Alright, so let's look at this, right? All 3 are dogs. So first of all, there's 7 dogs. So it's 7 out of 10 animals, right? 7 dogs out of 10 animals, right? So if I pull a dog out, right? I chose 1 dog, right? 1 dog, right? So now there's only 6 dogs left. Alright, out of, remember there was 10 total animals, but it's not 10 anymore. I pull 1 out. Now there's 9 animals left. So now, and by the way, I'm looking at probability of dog, and dog again, right? So dog, and dog, right? Anyway, now I'm going to pull out another dog. Alright. So now I'm going to pick, again, there's only 5 dogs left, and there's only 8 animals left. Alright, you see that? If I pull out a 3rd dog, well, I'm going to pick from this, my 3rd dog. But anyway, when I multiply that out, that gives me 210 over 720, which equals 7 over 24. Alright, 7 over 24, or 29.17%. Okay. 7. A bag contains 5 red marbles and 5 blue marbles. Alright. What is the probability of selecting 2 red marbles if the first marble is replaced? So this one's a little different, right? Probability of a red, red, and then the probability of a red again. But this is with replacement. So the probability of a red right now is 5 out of 10 because there's 10 total marbles, right? There's 10, 5 plus 5 is 10. And then I put it back. All right, I put it back in the bag. So now what's the probability of selecting the red marble? Well, there's 5 marbles in the bag because I pulled this one out. Then I put it back in. So now there's 5 red again, divided by 10 again. There's still 10 marbles in the bag because I put this one back in. All right, so that gives me 25 over 100, which is, oh, good night. That's 25 over 100, which is 1/4, or 25%. All right, 25%. Now for part B over here, part B says the first marble was not replaced. Well, that's a probability of a red again. All right, times the probability of a red again, but without replacement. So what's the probability of getting the red? Well, it's 5 out of 10 marbles, right? But this time, I got this red marble just sitting over here. All right, so it's no longer in the bag. All right, but how many red marbles are left in the bag, though? There's 4 in the bag. All right, so that's going to give me 20 over 90, or 2/9, which reduces to 0.2222, 22.22%. All right. Okay. Now let's look at this one right here. Determine how many ways president, vice president, treasurer can be chosen from a math club that has 7 members. All right. This is going to be a permutation, and I'm going to tell you why. The order matters, right? If I chose Coach Moore, then Miss Puff, all right, and then Miss Etheridge, all right, in that order. Well, that's different, right? For treasury, that's different than if I chose Puff, then Coach Moore, and then Miss Etheridge, right? Which is different. I can keep going. So this is a permutation. So remember, with permutation, we do N, choose R. All right, where N is the total number. All right, and R is how many we want, right? So, or the positions we want. So we want 3 positions. So remember, you can do this in your calculator, guys. All right, or you can do it by hand. By hand's a little longer, but if you did do it by hand, it would be 7 factorial divided by 7 minus 3 factorial. All right. Either way, you're gonna get the same thing. And here you go. I'm gonna punch that in so you can see it. Oh, there we go. So either one of those. Okay. So wasting too much time. I spent a lot of time on 210. All right. Either way, it's 210. All right. All right. Number 9. Number 9 says the security code. I like these. The security code is a sequence of 4 digits, right? So I got 4 digits, and I like to write it out, right? 1, 2, 3, 4. All right. And it says, let's look at the conditions. If the first digit must be a 1. So we already know what this is. That's 1. All right. That's a 1. So that we have one option for that. So and down here in blue, I'm going to put my number of options. All right. I have one option, right? Now, the last digit must be an odd. How many possible codes? So look, these are single digit numbers. So if you know anything about numbers, you'll know that there are 10 single digit numbers. All right, that's 10 numbers. See, 1 through 9 is 9, and 0 makes 10. So it's 10 single digit numbers. So the middle two don't have a restriction. They can be any other single digit number. So this can be 10. This one can be 10 options, right? All right, 10 options, 10 options. Now, for this one, wait, I don't want to confuse anybody, so let me not do that. All right. Now, the last one has to be odd, right? So, what are the odd numbers? Well, we got 1, 3, 5, 7, and 9. So that's 1, 2, 3, 4, 5. That's 5 odd numbers, right? So we using these conditions, right? The first number is a 1, so that's a 1 option. The middle two numbers can be any of those 10, so 10 options, and then 5 options for the last one. All right, or 5 possibilities. That gives me 500 possibilities. 10 times 10 is 100, times 5 is 500. Now, down here, number 10 says, California license plates are number, letter, number. For example, 3YNR975. How many license plate outcomes are there in California if repetition of letters and numbers are permitted? So if I can repeat, so think about it, right? Number, 26 options. Whoa, Coach Mark. 10 options. There's 10 single digit numbers. All right. Sorry about that. All right, and then letter, 26 letters. Letter, 26 letters. Letter, 26 letters. Number, 10 options. Number, 10 options. Number, 10 options. Now, the reason I did this is because, and notice that none of the numbers reduced because, or simplified, or lowered because I can repeat any digit. I can repeat any number. I can repeat any letter. You know, so as long as it meets this condition. So when I multiply that out, that's a whopper. 175,760,000. All right, 175,760,000 combinations. All right, Little Caesar. Hey, surprisingly, their garlic, cheese, herb bread is actually good. But anyway, I haven't ate that in like 7, 8, 9 years. I don't know, sometime in undergrad. So that's probably been 10 years. How old am I? No, it's not 10 years. Anyway, Little Caesars is offering a special where you can buy a large pizza with 1 cheese, 1 vegetable, and 1 meat. $7.99. Dude, don't eat that. There are 3 kinds of cheese, 3 vegetables, 5 meats to choose from. Oh Lord, what happened? Okay, I had a blackout. How many different variations of pizza specials are possible? So, alright, they got 3 So, for cheese, we have 3 kinds. Alright, for veggies, I can have 9 kinds, and for meats, I can have 5 different types, right? So, if I multiply those out, that's 135 different combinations of this pizza. Alright, 4 people are to be chosen from a committee from a class of 30. That's not good. Alright. How many possible committees are there? So, this is gonna be R and 30 is N. So, and this is a committee. It doesn't reference anything about order, so it's not a permutation, it's gonna be a combination, right? So any 4 people out of 30 to make this group. So that's gonna be 30 choose 4, right? 30 choose 4. So I'm gonna go to my calculator for that one. So 30 math probability 3 choose 4. There we go right there. 30 choose 4. 27,405. Go click. Man, I don't know what's wrong with this thing, y'all. Anyway, that's 27,405. Alright, 405. Now 13. It says there are 13 people on the softball team. How many different ways are there to assign them to play the 10 different positions on the field? Order matters. Think about it. A lineup in baseball or softball matters, right? So this one matters. So there's 10 positions. Well, there's 13 people, right? We're gonna permutate 10. All right, like that. So hold on, let me see. So that is going to give a little big number, right? We got 1,037,836,800. All right. Yeah, that's a billion. That's a billion right there. Different ways you can set this line up. All right, we're almost there, man. 14 says you are eating dinner at a restaurant. The restaurant offers 6 different appetizers, right? So 6 appetizers. All right, 12 main dishes, 6 side orders, and 8 desserts. All right, how many different dinners can you make? If you multiply that out, 3,456 dinners. Man. 15. How many ways can you select 2 cats and a dog from an animal shelter if there are 7 cats and 5 dogs available? So let's look at this. I got 2 cats and 1 dog, all right, that I am going to take with me. But there are 7 cats, all right, 7 cats in the shelter. So if that's going to be out of 7 cats, choose 2. Our order doesn't matter, I don't think, here, because I'm not going to rearrange it. The 2 I pick are the 2 I'm taking home. All right, and then I'm going to multiply that by, out of the 5 dogs, I'm going to choose 1. Okay, so that's calculator work. So I'm going to go to the calculator. All right, there we go. 7 choose 2 times 5 choose 1. I put it in kind of weird right here. That didn't work out. So make sure you adjust this. All right, when you put it in, make sure they're on the same level, not skewed like that. All right, and you get 105 combinations. Okay. All right, 16. An amusement park has 10 different roller coasters. All right. If you want to ride no less than 7 roller coasters, how many different combinations of roller coasters can you ride? So it's 10 coasters. So of course 10 choose 7. All right. And then plus, all right. Oh, and by the way, no less than 7. All right. So that means I can ride 7, or I can ride 8, or I can ride 9, or I can ride 10, because no less than, that means the minimum I'm going to ride is 7. So out of the 10, I can choose 7, or out of the 10, I could choose 6. I'm sorry, I can choose 8. Man, I'm tripping. All right, or out of 10, I could choose 9, or out of 10, I could choose 10, okay? So we're going to punch that in the calculator real quick. Boom. All right, so there we go. 10 choose 7, 10 choose 8, 10 choose 9, or 10 choose 10. And we do that, we get 176 different combinations. All right, so 176. All right, grand finale. It says find the number of permutations in this letter, and the letter and the letters in each word. All right, so that's basically how many different ways can we do this whole thing here. So first of all, we need to look at the fact that how many letters are present. So 1, 2, 3, 4, 5, 6, 7. There's 7 letters. All right, 7 letters. Now, how many letters repeat? Well, look at the L's. There's 2 L's. All right, and 2 O's. Right, so they repeat. All right, so what we're gonna do with the repeat letters, we're gonna make those factorial. All right. So what we end up doing here is we take our total 7 letters and we divide by our 2 repeats. So 2 factorial, 2 factorial. And we punch that in just like that. So I'm going to go to the calculator. Now I think the thing to remember here is, make sure you put your denominator in parentheses. You don't want to do 7 factorial divided by 2 factorial times 2 factorial. That's different than 2 factorial times 2 factorial, which is then divided by 7 factorial. Right? Or divided into 7 factorial. So when we do that, 1,260 permutations right here. Right? 1,260. Right? So for this one, senior, all right, there's 1, 2, 3, 4, 5, 6 letters. So it's going to be 6 factorial. And then what repeats? There are no repeats. So we just have 6 factorial. And if you punch that in your calculator, that's 720 different possibilities. All of it is 6 times 5 times 4 times 3 times 2 times 1. Summer has 1, 2, 3, 4, 5, 6 letters. So that's 6 factorial. And then what repeats? The M's. The M's repeat. There's 2 of them, so that's 2 factorial. Alright, so 6 factorial divided by 2 factorial. Alright, and that's going to be 360 different ways. So, that's your video, man. It's 34 minutes right now. I'm going to actually add some speed to it. I figured out how to fast forward through some stuff, so this should shorten this up. And I hope it helps, and I will catch you later.